All right, here's question 2 from the 2023 Calc BC exam. And so this second FRQ is generally either polar or parametric, and the past 2 years have been parametrics. And so I was predicting a polar, but it's the third year of parametrics. So here we go. We have a particle moving along this curve, and y is this, and x of t is not explicitly given, and we know the dx dt. We want to find the acceleration vector. So we know that the acceleration is the second derivative of our position. And so we're going to have an x comma y. So we're going to have a in the x direction, comma a in the y direction at t is equal to 1. And so these are triangle brackets. And so we have the function of y. So we have to take the derivative first. So we're going to do first y prime. And so y prime is going to be -2 cosine e, and y double prime, because this is just the velocity, y prime is just the velocity. Taking the derivative twice gives you the acceleration. And so the derivative of cosine is negative sine. It is not negative cosine, but here we go. But it is negative sine, -2 sine t. And so then we would just do t is equal to 1. And so then we would do y prime prime of 1 and as the y component. And then we would take the derivative of e to the cosine t and sub that in for our x. And so this is going to be -2 sine 1. And then the derivative of e to the cosine t is going to be the derivative of the inner function, which is going to be negative sine t. And then we're going to have a 1 there, multiplied by e to the cosine t, or cosine 1, cosine 1. And you could enter this into your calculator if you wanted to, but this is just the derivative of this evaluated at t is equal to 1. All right, part B asks, find the first time when the speed is 1.5. So speed is equal to 1.5. That's our goal. And speed is just the square root of x prime of t squared. And so I'm just going to label this x prime squared plus y prime squared. And this is the distance formula or Pythagorean theorem for vectors. If this is a bit confusing, you can kind of imagine that if we are plotting our velocities and we can find our x velocity is this much and our y velocity is this much, then our speed is going to be the net direction of the vectors. So this is just the distance formula or Pythagorean theorem. And so then we could start substituting in our values. And so this is just y prime of this is 2 cosine t quantity squared plus, um, and this we could just do e cosine e the quantity squared, and this square rooted, and this needs to be equal to 1.5. Okay, so I have the function from over here. I have this plotted as y, and you would be able to do this on your calculator as well, just this is the online version of Desmos. And so we can see this intersection point, and it asks for the first at 1.5. So I plotted 1.5, and you would be able to just look at the intersection as one of your little buttons on your calculator. This is at x is equal to, or in this case, this would be t is equal to 1.254. And so this question is just t is equal to 1.24. For part C, it is actually broken apart. So there's two different things we need to do here. We first need to find the slope at t is equal to 1, and slope meaning dy dx, and next we need to find the x-coordinate at t is equal to 1. So first let's do the slope, dy dx. dy dx is going to be equal to, I'm just going to write this y prime of t, or dy dt over x prime of t, or dx dt. So we have dx dt, and we have y prime of t. If we had written it down in another piece, we could just kind of use that. And so this would be 2 cosine, and we were doing this at t is equal to 1, 2 cosine 1, over e to the cosine of 1. And that would be this first part. And next we need to find the x-coordinate at t is equal to 1. So the way we do that part is we're going to integrate, because we have dx dt, so we're going to just integrate dx dt from 0 to 1. So we want time 1 and we have time 0. So the x-coordinate at time 0 is 1. So we're going to have our initial condition. We're going to have 1 plus the integral of 0 to 1 of dx dt with respect to dt. And so this, we need a decimal answer because they don't want us to leave integrals there. And so this is equal to x of 1, which is equal to 3.342. All right, for part D, it says find the total distance traveled from 0 to pi. And so if you integrate speed, you get distance. And when you integrate speed, you get distance, the total distance. So here's our speed from before. And so I'm just going to slap an integral on it from 0 to pi. And then let me figure out that answer. My calculator says that this is 6.3046.